Last talk before lunch, and we have Jason Keirstead here to talk to us about generative AI and how we can actually use this in security to be better at what we do. And so I asked Jason, what's something that most people don't know about him? And he said that he told me that he once sat in the command chair of the Starship Enterprise.
Whoop.
Please welcome Jason.
Thanks, everyone. And it was a life-size replica of the bridge they used to have on Las Vegas, and unfortunately, they got torn down and thrown away. But it was really cool because you don't actually when they used to have that, you weren't. It was part of this whole experience, and you weren't supposed to be able to go and sit in it. But it was my bachelor party, and let me do it.
Nice.
So I'm here to talk today about generative AI and LLMs, and like we were saying earlier, I know everyone's kind of AI'd out, but I really like to come at this from a point of view. People who know me, I'm a really pragmatic guy. I like to take the spin out of things. I've been doing this for a long time, and I know that people kind of have a hunger for what can I really do with this stuff. Like, what is it? Let's get beyond the marketing. And that's what we're going to talk a little bit about today. And that's assuming that my slides advance. Here we go. Okay. So just a very brief on me and my background. When I graduated from university, I joined a little company called Q1 Labs. This was way back in 2003. For people who aren't familiar, it was one of the companies that got bought by IBM in 2011. And I stuck around with the company for a very long time. And after about 20 years, I exited there last summer. And at the time, I was CTO of threat management. So I ran the worldwide technical side of the threat portfolio for IBM, including the SIEM, the SOAR, the EDR, X-Force, all of those different products. And I joined a company called Cyware. Cyware is a fantastic company that focuses on collective defense. And collective defense is an area that I'm really passionate about. It's passion project of mine. You can kind of see the little logos spattered through the middle of that slide. Those are all organizations that I'm a member of that are part of collective defense. And what collective defense means is I'm really passionate about this idea that as an industry, we all need to work together a lot more than we do. And break down the barriers, share more information, share more detections, share more about threat hunting, share more knowledge. Because, over the past 22 years, talking with countless customers, I just see like a lot of repetition, a lot of people dealing with the same struggles all the time. And, I could do a whole presentation about this, but we're not going to talk about this today. And now I'm with a startup called Symbian. And at Symbian, we focus on this idea of leveraging AI to accelerate cybersecurity. And we do that by building AI agents. So with that, let's try to level set first. What am I even talking about? What is AI? What does this mean? ChatGPT, how does this work? Right? What are the basic concepts that kind of constrain what is a large language model? I think that'll be helpful. I'm not going to go into like all of the thesis and details about it, but I think it really helps to make sure everyone in the room has kind of a fundamental understanding of how these things work. LLMs, at their core, are doing something very simple. They're guessing the next word in any given sentence. You give it one word, and then it looks in all of the billions of what's called parameters inside its model, where it's been trained on countless billions of pages of English or whatever language text. And it predicts, if I was looking at that word, what would the next word in that sentence most likely be? And that at its core is what all LLMs are doing. That's also, by the way, why an LLM can't actually autonomously just decide to go and do things, because unless you give it what's called a prompt, the prompt is the question you pose to it, or the initial sentence, it literally can do nothing, because it has to predict. Everything is based on prediction, and until you give it a prompt, there's literally nothing to predict based on. So that at its core is what an LLM is. So there's another really important aspect of LLMs when it comes to cybersecurity, and it's called the RAG, or the Retrieval and Augmentation Graph. So what is that? So if you just imagine an LLM and it's just predicting the next words in a sentence, that's kind of interesting. And when ChatGPT first came out, that's what everyone was astounded with, this whole chatbot that you would talk to, right? But the problem with that is they are stuck in time. They're stuck in the time that their training data was read into. And that's why when the initial ChatGPT came out, it could only answer questions up to around 2019, even though it was 2021. You'd ask it things and it would give you answers from the past, because it had no way to access current information. Well, the solution to that was this technology called RAG. And what a RAG is it's a very simple architecture that lets an LLM access current, up-to-date information. And I'm not going to go into the technical details about what an embedding model is and how that works and all this. But just think of it as a layer that lets the LLM, it lets, when you put a prompt in and question, that prompt gets pre-processed and changed using current information that's stored in what's called a vector database. And that change prompt is what actually goes to the LLM. And that's what allows the LLM to give you the information back. So for anyone who's used, say, ChatGPT Pro with the plugins, or if you've used Bing, right? So Bing search has a RAG built in. So does Google Gemini, so does Meta. And that's why when you go into Bing, or the search engine called Perplexity does this too, if you use Perplexity. When you use these search engines, they're able to go out to the internet and pull live information back. And this is how, at a fundamental level, all of this works. The reason I want to level set with this is because this is very important for cybersecurity, right? Because if we don't have a RAG as part of our system, it becomes almost useless, because we need to, if we're going to use an AI model to go and do things like understand threat intelligence, or help us triage an incident, or help us do vulnerability prioritization, that LLM has to be able to reach out and do stuff and get some of that context from your local environment. And that's how this works, right? So I just like to level set with that, because this is kind of what fundamental why a lot of these cybersecurity specific LLMs and AI models are important, and why you can't just use something off the shelf necessarily to help you do a lot of these use cases. You don't have this piece. And it's perfectly possible to build this yourself as well, open source. But it's kind of complicated, obviously. You need to have a lot of expertise in that and be a lot smarter than me to go and do that. So that's why people are starting to leverage these commercial tools and these frameworks that kind of do all that for you. All right, so that's the level setting. Now we're all kind of on the same page. What's an LLM? What is AI? How does it work, right? So let's get to the hype and the buzz around this, right? First thing I like to kind of get to the heart of is when a company or a product is talking about, we're using AI, yay. First thing you've got to ask is, are they talking about machine learning, or are they talking about AI as in generative AI and large language models? Because these are two very different things. They're both incredibly important, but they kind of tackle very different use cases, right? So if we look at machine learning, right? Machine learning has been in use in cybersecurity for decades. And what machine learning means is you take information in, you build a model around that pattern, and then you can make predictions based on that. And that's kind of how all network behavior anomaly detection works. It's how EDRs work at their core. It's how user behavior analytics work. It's all based on, I'll use the word traditional here, traditional machine learning. Even though there's still lots of innovation in this space, and like I say, it's incredibly important today. So don't take me using the word traditional and say, oh, that's yesterday's news. It's still incredibly important. But I'm just trying to distinguish it between when people use the word AI today, they usually mean something else versus what we call machine learning. And the reason that this is important is because up until December 2022, when OpenAI launched ChatGPT to the world, everyone was already using this word AI, but they were using it to refer to machine learning, right? And now people are using the word AI and using it to refer to something else, and these terms all get intermingled and quite confused in the marketplace. So when you're looking at a product and they're talking about how awesome their AI is, one of the things you should kind of try to understand is what they're talking about, because it's important. If your product is, say, a firewall, an IPS, an IDS, EDR, you need that machine learning. And in fact, I'll argue strongly, we'll get into why, LLMs are near useless for you. And anybody who expects that large language models are going to help them detect threats in their EDR or detect threats in their network are smoking something. It's not made for that use case. It can't operate that way. It's way too expensive, right? So, I'm not sure who in this room has experience with like the pro plan for ChatGPT or the OpenAI and how expensive it is to call these things on a regular basis. If you're calling it, say dozens of times a day to go and look up information. Imagine trying to call into these systems hundreds of thousands of times a second. That's what you would have to be doing if you were trying to detect threats on an endpoint or a network. It's completely unrealistic. They're not built to do that. And in fact, what I'll call traditional machine learning is much more suited to that use case. So I don't believe that large language models are going to have any kind of fundamental impact on detecting threats for a long time. When we get to the end slide, I'll kind of go back and say that I was wrong, but bring it to life. So third point, there's a lot of hype around, how important these LLMs are going to be in changing the industry. I don't have a crystal ball. I can't make any predictions. I will say there's an incredible amount of venture capital funding flowing into this space. There's new companies starting up all the time focused on this area. One of the reasons is that it's viewed as being able to help tackle what's called the skills shortage in cybersecurity. And there's a lot of skepticism in the industry on how real the skills shortage is, especially with a lot of the recent layoffs in big tech over the past 12 months. Is there really a skills shortage? Is it a buzzword? I think that the reality is it's in the middle, right? I think that what's lacking is there is a shortage in terms of very senior, well-rounded cybersecurity professionals who can actually, the threat hunters who have been doing this a long time and can go and find those advanced threats. Those are unicorns. They're hard to find, right? So there is a shortage in that area, and everybody, kind of wants those people to materialize out of thin air, and it's challenging when you've now got all these layoffs and there's not a lot of entry paths for some of the younger folks to come in and learn those skills. So I think it's a mixture, but no matter what way you cut it, the view is that LLMs can help with that gap. And the reason is because they can be a big accelerator. LLMs are not in a place today where they can just completely replace a human analyst, but they can definitely help a human analyst do things a lot faster than they can without them. The other thing I'll just add here is that I believe that LLMs have we have the opportunity to finally look at resetting the defender's dilemma. So I don't know who's familiar with this concept of the defender's dilemma. It's called, the phrase is that the defenders have to be right all the time. The attackers only have to be right once, right? Because you have to protect your environment 24/7, 365. They only have to find that one chink in the armor to get through. That's called the defender's dilemma. What we have with LLMs and generative AI, as it starts getting rolled out and integrated into more of these products, you potentially have the opportunity to reset the defender's dilemma. And the reason is because for the first time in a very long time, this is a new technology where the advantage goes to the defenders and not the attackers. So attackers can leverage LLMs to up-level their attacks, and we're seeing a lot of enhanced business email compromise attacks and spear phishing attacks using generative AI. And it's kind of scary how people can generate entirely fake Zoom calls and go in and do a BEC attack now and steal millions of dollars because they look like the CEO and sound like the CEO, and they're saying, I want you to do this wire transfer, and there's almost no way to authenticate it anymore. But that said, there's a lot of danger, yes. But as defenders, we are now going to have access to this technology that can help us defend the environments where scaling that technology horizontally is not a nominal cost. So if you're a company and you're using AI to defend yourself, and the attacker is trying to use AI to attack you, well, that attack is very expensive because AI is not cheap to run, right? So this is the big difference with an attacker today trying to compromise a swath of people can create a spear phishing campaign and send that out to 10,000 employees, and it costs nothing, literally nothing. But if you want to go and create a BEC campaign with LLMs and use LLM to target 10,000 employees, well, guess what? That's actually probably going to cost you like thousands of dollars to compute. So now that you've shifted some of the equation, right? So I'm kind of an optimist, but I think that this is one of those technology moves where if we do things right, we might actually come out on the other side ahead of it. So let's kind of get into the separating the fact from fiction. What are realistic capabilities of LLMs? Where are they not suited? So I kind of got into a little bit of this earlier, that, if you hear of companies and they're kind of pitching you this idea that they've got this new LLM and it's going to kind of detect all these new advanced threats, that's not a realistic capability of LLMs because it doesn't scale. Because they are expensive to run. And it doesn't matter if you're, even if you're running it locally, you now have to have a huge GPU farm of NVIDIA GPUs. And a lot of people don't have access to that. So you're usually paying for it and outsourcing it to a company like OpenAI or AWS or Azure. So they're expensive to run. As a result, they're not really well suited to real-time threat detection, threat monitoring, running on the endpoint. They're not going to result in huge sea changes in detecting threats. Another challenge that you have with those, so we talked a little bit earlier about how RAGs work and access to that data. So because that local context is so incredibly important, what an LLM can and can't do depends a lot on how much it can have access to that local context that you have. So if you're relying on these cloud systems and those systems don't have any of that access to that local information to build that context, they're not going to be able to make the best decisions. They're going to be kind of doing like generic response plans and things like that. So that's another challenge. And then finally, we've got this whole co-pilot thing. So I've got a quote there from Mark Benioff. He's the CEO of Salesforce. Obviously, he's kind of a competitor to Microsoft, so you've got to take this with a grain of salt. But he says Copilot is basically the new Microsoft Clippy. If you've been using Copilot built into Windows, it's kind of questionable how much value you're actually getting out of this thing. It's entertaining, but beyond that, like it it doesn't have the ability to go and do stuff, right? And this is the challenge with a lot of these initial rollouts of generative AI in cybersecurity, is they're all these chatbots, right? So every single cybersecurity product now has an AI chatbot. All. And I mean, on the previous slide, you kind of saw the names of some, right? They've all got their own name, but at their heart, they're all kind of the same thing. They're these, clippy like chatbots. You can go in, you can ask it some questions, it gives you some answers. And it can help, it can save analysts time, no doubt. It can accelerate your analysts because you can ask it information about your environment in plain English, and you don't have to learn all these special search queries and lingo, and it can give you that information back. It's an accelerator. But the vast majority of these co-pilot systems, they can't proactively go out and do anything, right? So when you kind of look at, okay, what is the value I'm getting for this thing I'm paying for? It's not actually able to do anything. It's just something that, kind of helps me answer questions. And is this really the promise of AI? I thought that AI was going to come and cook my breakfast and make waffles. And instead, it's just like a chatbot. Like this is, we had chatbots back when I was in high school. We were using Eliza back in the commerce. I don't know if you my gray hairs. So this is a little bit hard to read. If people want, they can download. I can send people this text so you can read it in detail. We also have this up on a blog on our website. But I kind of break down what are co-pilots good for in cybersecurity, what are AI agents good for in cybersecurity. And these co-pilots, they have a lot of very strong use cases, but because they're not proactively going and doing stuff, they have a fundamental difference between them and what's called an AI agent. An AI agent is something that it acts more autonomously. It acts more like a person. It goes out, does things, comes back, takes the knowledge it gained from that thing and goes and does something else. More like a person. And the way that those are built, super quick, is that right picture we saw earlier. So imagine there's a whole bunch of those, and they talk to each other. That's how an agent works. So because it's got the feedback loop, it's able to act more like a person. So this is a key thing to think about when you're looking at, how much value am I going to get out of this thing, or are my people just going to be sitting there chatting with it all the time? Is this actually helping? All right, so we deconstructed a little bit of the hype. So what are some real case studies? Like, what are people actually doing this for today? And, as we go through this, I'm going to talk about as well some free open source tools that I know are in use in SOCs today that people are getting value of. So first case study is operationalizing threat intel, right? So we just had a great talk about threat hunting. And one of the key facets of threat hunting, as was discussed, is to have threat intelligence, right? If you want to start these hunts, you need to know what the threat actors are doing. Well, one of the challenges we have in this industry is a lot of the best threat intelligence is still disseminated in a human-readable form, right? And that's either in PDFs or you see it in a lot of blogs, right? So a lot of companies will publish the research from their intel analysts on their company website or their blog, and they don't necessarily, along with that blog, provide like a machine-readable format like STIX or CSV or XML. They often don't provide that. All they have is the blog, because the reason those companies are publishing it is to kind of show the skills of their people. They're not necessarily trying to give you a bunch of free stuff. So how do you take advantage of that? Well, one of the things that large language models are fantastic at is consuming large volumes of text and then letting you work with that text. So taking threat intelligence from a human readable form and then extracting the indicators of compromise, the TTPs, the threat patterns, so that you can go and then use that to start those threat hunts, is a great use case. And there are free open source tools. I've got some linked here that can help you do that. And there are SOCs that use these today in production. I've heard of an AI special interest group at first.org where we kind of talk about this stuff regularly, so people are building and experimenting with this all the time. And there's some commercial tools as well that will try to make this a little bit easier. But the other thing I'll just highlight is that there's been some capabilities like this for a while, but they use something called natural language processing. NLP is a kind of a precursor. Let's just say, some people will shoot me for saying this. It's not a precursor to LLMs, it's a totally different technology. But NLP is kind of the way until recently that all machine learning systems read and consumed large volumes of text. But I gotta get moving a lot faster here. All right, use case number 2. Enhancing instant response and threat intelligence. So this is where you can use LLMs to help you build and improve your threat detections. So again, we just had a great presentation on the threat. I feel like in some ways that presentation got set me up here. So we just heard about Sigma and what Sigma can do for threat hunting. Well, these Sigma rules that you're trying to use, yes, there's a big open source repository that's on the internet, but what about when you want to build your own, right? LLMs can actually help you build and improve Sigma rules and detections. And there's a tool here, I've got a link at the end of the deck that you can go to get that tool. It's a free open source tool that helps you take threat intelligence, so you've got that piece of threat intelligence that we were talking about, and then you've got a Sigma rule, and it can help you kind of craft and curate that and make sure that that rule will match those detections and let you hammer through, leveraging the power of LLMs to help you do that. Another use case that we see LLMs being used for is to automate incident triage and response tasks. So when you have that incident come into the SOC and you're not sure, is this a false positive or a true positive? This is what consumes like 70 to 80% of the SOC's resources, is just trying to do that level 1 investigation of, you know, I've got these 200 alerts coming into my SOC today, and there's only 2 that are real. All of these are probably false positives, but I can't be sure. So we have to go and do an preliminary investigation to determine whether or not they actually are false positives. Well, if you have those steps, if you've already figured out what those steps are supposed to be for your organization to determine whether or not those things are true or false positives, you can use AI agents to completely automate that problem away from you. And it's very simple to do. It's a lot simpler to do than the classic, SOAR use case of having to build these big complex playbooks that know how to write Python code and stuff. Because one of the cool things about LLMs is they're very good at generating all of that for you. They're extremely good at generating these flows and going and automating these things. So this incident triage to get from the, again, it's not about replacing the human analyst, it's about throwing that gasoline on the fire so that we can get from L0 to L1 so much faster, right? And finally, generating threat hunting flows. So again, we just heard about hunting, right? When you have a threat actor that you're trying to go and look for, and when you've gone and done that first investigation, right? So I've got this thing I'm searching for. I've got this Sigma rule. I go and search it, and now I get back these things, right? So I get back these events from my SIM, or I get back these logs from my EDR. What should I do next? What's the next step in my hunting hypothesis? Based on that information, what's the next thing I should go and look for? That is an amazing use case for LLMs, because this whole iterative process of, remember how they work with prediction based on the corpus of all human knowledge that it's read, right? So that's the exact same thing that somebody does. They're developing hypotheses for doing something like threat hunting. So it's a great use case for LLMs, and we're seeing a lot of success building things along this line to build the threat hunting hypothesis chain to help new hunters learn how to hunt. Because hunting is one of those things that, again, back to the skill shortage. If you've been doing this for 20 plus years, you kind of intuitively have those hunches and those gut feelings about what should I go look for next. But if you're new to the field, you don't have those hunches. So a tool like this can help you build that muscle memory because it can help suggest those hunches for you. Final case study, and this is another thing being used in the wild, is this idea of automating compliance tasks. So cybersecurity questionnaires, right? They're the bane of a lot of people's existence. Anybody who has to sell anything knows that nowadays, because cybersecurity is so important at the top of everyone's mind, you have to be able to respond to these questionnaires that your customers will send you, right? And they're come in these spreadsheets. And everybody has their own spreadsheet because there's absolutely no standard. So you'll get this spreadsheet, Excel spreadsheet. Can you answer all these questions? And they ask you things like, what's your password policy? Are you SOC 2 compliant? Do you have this? You know, where do you hire your people from? Blah, 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 all this stuff, right? And it's easy to answer these one-off, but when you're a company that has to answer literally dozens of these a week, which is common, like that's not an outlier. If you're selling a lot of things or if you've got a lot of potential deals, you have to answer a lot of these. It's extremely time consuming. And what is a great task for LLMs? Well, LLMs can be given access to your corporate compliance information, read it all, and once it's read all of that, it now knows the answers to all of those questions. So it's really easy now to have an LLM automate answering all of those. So somebody sends you this spreadsheet, you put it to the tool automatically answers all the questions, gives it back to the human for a final double check. And it's a lot easier to verify something than actually go through and fill it out. A lot faster. And this can save oodles of time and be a huge accelerator. So this is another thing that's being rolled out right now with great success. And there's a lot of different companies that are enabling this thing. There's some open source tools too. All right, get through the risks quickly. So this is not a panacea, right? Like I said at the beginning, I'm a realist. I always want to make sure everyone has all the information. So what do you do about data privacy issues, right? There's a couple of different mitigations to that. First is make sure that your tool or your system has what's called a zero retention license and access to these large language models. What that means is when you go and submit, a lot of people have this fear that when they submit questions to these AI systems, that their confidential information will then be used to train the model for the future for other people. And that is true if you're using the free versions. But if you're using the paid-for license enterprise versions, it is possible to get these zero retention licenses so that your information is guaranteed to never be used for training in the future. And that's an important thing for people to realize. Like when you're using the free version, it's something to be concerned about. If you're using the paid version, generally it's not a huge concern. Always read your T's and C's, but generally it's not as big of an issue. The other, if you're really paranoid about it, the other thing you can do is you can run this stuff locally and you can use local models, open source, Lambda, etc. Hallucination. Hallucination is another big problem with generative AI. Because it's all based on that random word prediction, it can kind of just make up stuff. We've all seen this, so I don't need to go into the details of the funny examples. But how do you mitigate that, especially if you're using it in cybersecurity? So one mitigation is you can do what's called, you have a source of truth. And if the system you build has a source of truth in it, it can go and it can double check what the output is from the generative AI. It can use AI to check the AI output against the source of truth and make sure that the output makes sense and agrees with the source of truth. So it's kind of like a double check and balance. The other thing that's really important, and most of these systems still have today, is human in the loop. So while you want AI to be able to go and do things for you, and not just sit there and wait for you to ask it, questions, you still want that human in the loop right now. You want the AI to be able to accelerate the human, and then the human makes the final decision. By having that human in the loop, you can make sure that it's not going off or being T1000 and bringing down your whole company. And then finally, continuous improvement, right? So when you create these feedback loops, the hallucinations actually start to decrease over time, because as the system learns more about you telling it, hey, this was actually wrong, then in the future for your environment, that'll end up being less likely to be hallucinated in the future. Finally, ethical considerations, I already kind of touched on that, but there's this concern that, oh man, AI is coming and taking all of our jobs, right? So the most important ethical consideration here for me is, if AI comes and replaces if AI helps accelerate the entry-level tasks in cybersecurity too much, then how are we going to grow people to do the more advanced tasks? That's something that people have brought to us. And it is challenging, but one of the things you can think through is, just as AI can help accelerate those entry-level tasks, it can also train entry-level people, right? So we have the opportunity to have AI systems be able to build training to help people actually accelerate their career and get from junior to senior so much faster than they would just kind of toiling their lives away at an L0 sum. So I'm going to skip this one because we're running out of time. So future trends, the future of AI and SecOps. So a lot of the stuff that I kind of talked about today, you could in theory do using SOAR, Security Automation Response. So it's an interesting question. If AI is able to come and automatically essentially build playbooks and automatically go and do things, do we still need a SOAR? Again, I don't have a crystal ball, but this is something that I think is going to be playing itself out in the next 12, 18, 24 months. All the SOAR vendors are integrating this technology into their products already, right? So, is there a future, like, are we still going to be building these drag and drop, workflow playbooks to automate security in 24 months? Why would we do that when we can literally just type in a box and say, I want you to do this, then do this, then do this, and if you see this, then do this other thing. Boom, then just generate, why would we go through all that? The AI can do all that for us. It's a very, very big question. The final one is, so earlier in the presentation, I kind of hammered on the fact that LLMs are not good for detection. That's true. But generative AI, so the difference between generative AI and LLMs, right, is think of generative AI as a superset. So generative AI is more the superset of AI that has to do with neural networks that LLMs are based on. So you can have generative AI systems that are not large language models, right? Imagine training a generative AI system not on language, but on all of the CrowdStrike events that happened in my enterprise in the past year. Now that system is very likely to be able to predict threat actor behaviors, right? So there is a potential to leverage generative AI for detection when you take it outside of the LLM level. And there's some, very high-level research going on in this area. I haven't seen any real commercial projects that have come out using it at all, but it is something we can hopefully look forward to. The ability to use this technology to help, not just accelerate response, which is what most of this presentation is about, but to help detect threats as well, because you can kind of anticipate what threat actors are doing. So that's an interesting potential thing for the future. All right. With that, I don't know if I have any time left you all, but conclusion before we open up questions. This presentation, this space is moving so incredibly fast, right? So everything I just talked about is going to be completely out of date in 30 days. And if you want to keep up to speed on what's going on in generative AI and SecOps, I've got a couple of links here. So we have this Security Accelerator Slack community that I've stood up. It's completely vendor agnostic. It's just an open sharing community where we're talking about everything that's going on in the space. We're also going to be having a podcast that starts up. in conjunction with this community very soon. There's a link to my company there that's working on the AI agents, and there's this other fantastic resource from this fellow named Dylan Williams. Dylan is the guy that created that Dana open source project I talked about with the using AI to help your detections. He has an amazing Start Me page. If you go to that page, it has 200, 300 different links, all categorized, having to do with AI and cybersecurity. And you can go all the way from 0 to N. You can start from the very beginning and learn, all kinds of different stuff. All right, so do we have any time for questions?
We do. Downstairs is running about 5 minutes overtime, so.
All right. I know that there was talk of a microphone for if there is any question. All right, maybe there aren't any questions, and everyone hates AI, and I hate me. Well, just one day.
So, as an offensive security person, what's your use of the to actually start using data? How are you
Did everyone hear that, or should we use the mic?
So, as an offensive security person, what sort of use should I be leveraging AI for?
Yeah, so for red teamers, so this talk has mostly been in the blue team. For the red team, there's a couple of different facets to look at, right? So first kind of question is, are you trying to red team your classical infrastructure using AI, or are you trying to red team AI, right? And both of those are very important because, so so whenever a new technology comes out in the market, I think of it as like this three-legged stool, right? So you can use that technology to attack us, you can use that technology to defend us, and then you can use that technology in the business, in which case we have to defend it, right? If you think about that, that was true when cloud came in. Oh, well, what does, we now have to defend the cloud's going to be used in the business. Now we have to defend the cloud. Oh, how can we use the cloud to improve cybersecurity? Oh, how can attackers use the cloud to attack us? So, it was the same thing with blockchain. Now it's the same thing with AI, right? So you got to kind of think about those three things. This talks mostly about how do we use it to defend us. When we're talking about attacking, red teaming, we're thinking there's other two legs to the stool, right? So attacking the AI and using the AI to attack. Let's talk about using the AI to attack. So there are a whole bunch of open source red teaming tools that leverage LLMs to launch attacks. And there's also tools that are using LLMs to find, I don't even like to use the word 0 day. It's like -1 day vulnerabilities in source codes. There was actually, I don't know if y'all caught the news, because the election's been drowning out the news, but yesterday, Google Project Zero announced, so they had the first ever 0 day vulnerability completely discovered by AI, published by them. So they had an AI that was scanning thousands of open source projects, and what was the project? What? No, there was what was the project they found the vulnerability in? It was it doesn't matter. So there was a major open source project that everybody here would know, if I can remember it.
SQLite?
Yes, it was SQLite. I don't know who said that. It's a gold star. Yeah. So they found it in SQLite, and the vulnerability was in a pull request that had not been merged yet, and was not in any release, right? So think about that. Like a developer wrote some code, they put in a pull PR, never been released, it's just sitting there, AI finds it immediately, they go and disclose it to the team's able to fix it, and before it ever gets released, right? So it's kind of a pre-0 day vulnerability. So that's the good guys, right? But the attackers are doing the same thing, right? So, Google Project Zero They do have access to compute resources in Google, but other than that, like the stuff that they're doing, anybody can be doing it. So like threat actors are already using AI to find zero-day vulnerabilities in code on the internet at scale, right? So that's one thing we've got to be extremely concerned with and cognizant of. So as a red teamer, you should be looking into that, like how can we do that to get ahead of it in our own code base and pointed out projects that we leverage. The other part of using AI for red teaming that's been happening is so those are scanning source code, but you can also use LLMs to automate discovery of vulnerabilities through like web scans and scanning the attack surface of the application. And there's projects that are already doing that as well. So the interesting thing though is there's a lot of hype around that, around AI coming and having these zero-day attacks, but that's not really what everyone should be most concerned with. What people should be most concerned with is what I talked about at the beginning, which is the business email compromise and the spear phishing, right? So if we got a minute to talk about it, right? So business email compromise, for anyone who's not familiar, is when you impersonate a corporate officer or somebody else in the company, and you go in and you send an email or a Slack message and you say, hey, I'm the CFO, I'm Bob, we need to do this wire transfer to pay this vendor and we're out of time, can you please accelerate this? And it's typically to they send this message to somebody they know has authority to do it, like a deputy CFO or something. And, classically, this was done via a lot of social engineering, right? So the attackers would go in, they'd look at all the LinkedIn profiles in the company, they'd kind of build up their repertoire, socially engineer, okay, this is exactly, if I craft this email in this way, it sounds exactly like an email from the CEO. And I know right now he's on vacation in Hawaii, so he's on a plane on the way to Hawaii. So I know he's not going to see the email, he's not going to camera. So they send it down, and with a sense of urgency, it'll probably go through. And occasionally those went through. Well, what happens today is that is now able to be scaled en masse with generative AI that can read all these social media profiles and build all this knowledge, and you can now do what was previously a spear phishing campaign that took a couple of weeks of research. You can launch en masse to 50,000 people at any company you want. And then if they take the hook and they say, oh, I want to actually, can we have a Zoom call to verify this? We just spin up your generative AI generated video of the CFO and impersonate him on the Zoom call, and they say, oh, looks good, let's do that wire transfer. And that's literally happening. It's happened, tens of millions of dollars have already been stolen this way. The scary thing is business email compromise has overtaken ransomware already in terms of a profit center for threat actors. And this technology's only been around for what? 6 months, a year? And the cost to use it's dropping and the expertise is growing. So this is what I'm most concerned about. And, how do you defend against it, right? So a lot of people are saying we kind of go back, we got to get back to old school sneaker net. We have to have code words, right? And, when you're on that Zoom call and you're not totally, something fishy about the Zoom call, ask someone a question where the only way they would know the answer is if you had met face-to-face previously. Hey, where is it that we went to dinner last time when we were at that event? I know, I have, I haven't done this myself yet, but I have friends that, they've actually set up a thing in their family where there's a secret word in their family. And if somebody calls and they say that they're me, they have to know the secret word. So that, otherwise you can't trust them. There's been people who have had, this gets me worked up. There's people who have had fake kidnappings and threat actors, right? Because they can imitate your voice so easily based on information on YouTube. They'll download that information on YouTube, they'll generate the sound of your voice, they call up they generate the sound of your child's voice, and they call you, and they try to extort you, say, you know, you've been kidnapped, help me daddy, says I need to pay him $100,000. And it's all fake. There's no actual kidnapping. But, you know, this is your kid on the phone, right? What are you going to do if you don't have this code word system in place? And, you know, it's scary, but what scares me more is like this is now able to be done at scale. This is what everybody doesn't totally get. It's the scale that's scary. Because when it was done by humans, you couldn't scale it. When it's done with AI, you can. Flip a few switches and boom. Anyway, I'm way over time.
Any questions on